Hello students, this is Dr. Munir Omar with CS222 Database Management Systems. Today in lecture 30 we will be studying about SQL Giants. You can also call this topic as selecting data from multiple tables by using SQL Giants. Actually we will study or we will practice the advanced versions of DQL, the select query, where we will use some joins to get data from multiple tables. The main purpose of this lecture are to learn about the basics of joins, what are joins and why we use joins, and without joins what will happen, or simply we can say that what would be the advantages of using joins in our queries. Then we will also look into the types of joins. There are some types. We will discuss all those types and also to practice these joins. And the main thing about join is to get data from multiple tables in different ways. So these types will let us know that how can we get data from multiple tables in different ways according to our requirements. So these are the contents. The first thing is SQL Giants, which is the introduction. Then we have some types. The first one is CrossJohn. We will discuss this. Then inner join, natural join, and then outer join. In outer join we have subtypes. The first one is left, right, and the last one is full outer join. Before starting this lecture, we will look into our previous coverage. So far we have studied about the basic concepts. Then we studied the ERD, entity relationship diagrams, and then we studied the SQL, structured query language. So in the basic concepts, there were many topics like what is database, what is DBMS, advantages of DBMS, advantages of database, architectural level of databases, then level of data, database users, and DBA, the database administrator. There were some other topics too, like the data independence functions of database. Then we studied about entity relationship diagrams. In entity relationship diagrams we studied about the entities, the types of entities and their usage, attributes, type of attributes, domain of attributes, and there were some other topics associated with attributes. Then relationships, there were some types of relationships and how can we use these relationships with the entities. We also studied these things. Then we studied keys and also did some practical examples of ERD. Actually, if you remember, we took some real world scenarios and built some ERDs for those scenarios. Then we studied about the SQL, structured query language. In structured query language, as you know, there are many types, so we studied almost all those types. We studied the DQL, data query language, data manipulation language, DML, then DCL, data control language, and DDL, the data definition language. We also practiced all these types of queries on Northwind and Sakela databases. Note one thing, under SQL there is another topic, that is TCL, transaction control language. This topic is associated with our theoretical topic transactions, so that's why we have not studied this TCL. It will be covered later once we study the transactions. Let's look into some basic things. Actually, we have already studied these. As you know that in relational databases we use tables for data storage, and all these tables are somehow associated with each other. So I'm taking an example of two tables. Here we have two tables, both are connected by connection, we mean that there are some attributes which are common for both tables. Actually, we have already studied this thing. So we use primary key and foreign keys for connecting two or more tables. Actually, this connection is made in this way. Like here we have a value in foreign key, let's say it's 1, and here in the second table this value exists somewhere, let's say it's here 1. So this whole record will be associated with this record. So in this way we can connect multiple tables. So this one record is associated with this one. Let's say here we have 2 and this 2 is present here in the list. So this record will associate this one due to this foreign key and primary key. Suppose here we have 3 and there is no 3 in the second table. There isn't any value similar to this one. So what will happen? There will be no association of this instance to any instance in this table. We may have some value here and those values will not be present in this foreign key. So there will also be no association for those values. An example for such type of tables can be a student record or employee records. Suppose here we have ID, then we have name, father name, date of birth, and then in foreign key we have zip or zip code. So in second table here in primary key we have zip, the zip code, and city name, province, landline code, and country. Now let's start our main topic, that is SQL Giant. SQL Giant is used to fetch data from 2 or more tables. Actually, when we fetch data from such tables, those tables will have some association or some common values with each other, and the resultant data will be appeared as a single set of data for that operation. It is used to combine columns from 2 or more tables by using values common on both tables. As I told you that when we collect or when we select data from multiple tables, then we also consider some values common to both those multiple tables. So the common values would be definitely under common columns. So we consider some common columns for getting the combined data from 2 or more tables. The keyword used for joins is join. Actually, we use this join keyword in select queries, and with the help of this join we combine or join multiple tables and we get a combined result from the execution of Curie. We will cover these types of joins in our lecture. The first one is CrossJohn. With the help of CrossJohn we will get the Cartesian product of 2 or more tables. Suppose we have 2 tables, table A and table B. So with the help of CrossJohn we will get the pairs of all the items from table A which would pair with all the items of table B. Then in inner join we will get the matched data from both the tables. By matched data I mean that the data which is under the common attribute and that is present in both the tables. Then in outer join we have three types: left, right, and full. In left outer join we will have actually two tables, the left table and the right table. The left table would be the first table in the Curie. So the matched and unmatched data will be selected from the left table, and matched data only from the right table will be selected. In the case of right outer join, we will get matched data from left and matched plus unmatched data from right. And full outer join is the union of left and right outer joins. Query for cross join is quite simple. We must type select. As you know that joins are used in select queries, the DQL, data query language. So select the columns. As I told you that we can use static for all the columns, or we can specify columns here. So you can type ID, name and address. From table 1 cross join table 2. So this is actually the important thing, that you must type cross join between the two tables in this select query. So we will practice this in workbench now. We have a database here named as lab joins. It has two tables, employee address and employee info. Actually I made these two tables according to our lecture. So we will cross join these two tables. First let's check what do we have in these two tables. So I'm typing select static from emp address, control enter. I need to select this table, this database first. So use lab joins, control enter. This database has been selected. Now execute select static from emp address, control enter. This one got executed. Here we have ID and city. IDs are 1 2 3 4 5 6, and we have some cities in this table. Now let's check what do we have in emp info. Select static from emp info, control enter. So here we have IDs as 1 2 3, then 7 8, 4 5 6 are missing in this table, and also here we have some names for these IDs. Now we are going to cross join these two tables. What will happen? This first instance will be paired with each of the instance or the selected attribute in the second table. So here I must type select. I'm going to select the name only. So name comma, and from address table I'm selecting city. Select name city. Then from table 1 is emp info, and then cross join the second table, which is emp address. So this query will cross join both the tables. Actually it will cross join the instances of both these two tables. So I'm going to execute it, control enter. Here we get the result. So if you look into this result, this Ahmad is combined with cohort, then the same Ahmad is combined with Peshawar, again with Islamabad. So we can assume that all the names are paired with all the cities. Names are in table EMP info and cities are in EMP address. Now let's execute this query on Northwind database. In Northwind database we have many tables, and inside this database all these tables are interconnected. So we are going to practice this CrossJohn on customers and orders. If you look into the diagram of this orders, and we have customers, so these two tables are actually connected. We can look into their diagram, both are connected here. So in customers we have ID as a primary key, and in orders we have customer ID as a foreign key, which is connected with the ID of customers. So here in customers we are going to select ID and then company. So here I must type ID comma company. These both are from customer. So actually there was another ID in orders, so I must specify that this ID is from customers, so it should be customers dot ID. Company, no need to specify. I think there is no company in orders. You can also specify it by typing customers dot company, and after that in orders table we select, let's say, the order date. So here I am typing order date from the customers table, and CrossJohn the orders table. Now we can execute this query. Select customers.id comma customers.company and orders.date from customers, CrossJohn orders. So first we need to select this Northwind database. So here type use Northwind, execute it. This one got selected. Now execute this query. This one is order date. Now execute it again. Here we get the result for company A. We have an order date, and if you look into the result again for company B, we have another order date. So all the order date are paired with all the companies.